Good afternoon, everyone. Good afternoon, Samreen, Yanshika, Jay, and all others present here. Good afternoon. As usual, the first 3 minutes is for the students to join. Let them join, and we'll start with the same question where we have ended yesterday. Question number 9. Good afternoon, Ravinder sir. Jay is asking, sir, in this chapter, no deletion is there. There are two theorems have been deleted. Means questions you have to do, but proving of two theorems will not come. Which is which I'll tell you. Till now, everything we have to do. Only two theorems. Yes. We have not reached there till now. But you should know what are the two theorems. Only you have not to do the proving of these two theorems. Only two. Okay. Whatever proving we have done till now, that is required to do. PPD and converse of PPD is not deleted. Write it down by the time what is written on the screen. Yesterday we were doing this question, question number 9. And if you want your attendance to be done properly, then only those students are marked present to whom I am able to see. Simple. Those who are not visible, they have been marked absent by Ravinder sir, Daljit ma'am. Okay. They are looking at each and everything, and I am receiving messages from them that these students are marked absent because they are not switching on the videos. So switch it on if you want your present to be marked. Now question number 9, in the figure no, yesterday we have written this, that given AB and DC are given parallel, to prove AO upon BO and CO upon DO we have to prove equal, and after that we have to draw here something to prove them equal. Okay, what is given? Only AB and DC are given parallel, and this we need to prove. So in this question we have drawn yesterday the line EO parallel to CD. Afterwards we have written that EO is parallel to CD, and also that AB is parallel to CD. This is already given this by construction, and this is given in the question, and because of this we can write that all the three lines are parallel to each other. All the three lines are parallel to each other. Now just see these triangles to prove. First of all, look into this triangle. In triangle ACD, in triangle ACD, EO is parallel to DC. See, till now, no, we have done only two theorems, BPD and converse of BPD. So we have to apply only these two theorems. So in triangle ACD, EO is parallel to DC. Therefore, by basic proportionality theorem, AE upon ED, see E, there is one point and O, the other point in the triangle. So AE upon ED equals to AO upon OC. Because of this, AE upon ED, AE upon ED is equal to AO upon OC. This is the first. Just write like this. Do not write OC, just write CO. The way it is written here, AO and CO. In the same way we are writing now. So AE upon ED equals to AO upon OC because of BPT. Now see in this triangle. The other triangle which is required to see is this. In this triangle also we have the parallel lines. Yes, no, we have to look for those triangles where we have parallel lines. Simple. This is the criteria to see. Now see in this triangle, in triangle ABD, in triangle ABD, now EO is parallel to AB. See this. We have written here each and everything that EO, CD and AB, all the three lines are parallel. So we can say that EO is parallel to AB. So by BPT, as the lines are parallel, therefore by BPT we can say that, see this, EO is parallel to AB and triangle is just reverse, means triangle is not made like this, it is made like this. So we'll move from here, DE upon EA. Okay, so ED upon AE. So this upon this is equal to DO upon BO. Now see one thing. Yesterday we have done questions and where after making two equations, no, what we have done comparison, whether something is same or not. Here AE upon ED and here we have ED upon AE. So this should be reverse, means reciprocal of this should be done now. So reciprocal both sides. So it will give you AE upon DE and this side also BO upon DO. We are coming late in the class. Take care of the timings. So AE upon DE is equal to BO upon DO. How I have done this? I have done reciprocal of this. Why I have done reciprocal? Because no, this is not matching up. Look here. Here we have ED upon AE and here we have AE upon ED. So I have reversed it now. Now see this, both the things are same. This side also and this side also. I know this is same, no, and here also we have to do reciprocal. As we can't do reciprocal on one side. Now let this be equation number 2. After this, from equation 1 and equation 2, as AE upon ED or AE upon DE or ED, just write here ED only, the same way. Here I have written ED, no, here also ED. So AE upon ED is same both sides. So AO upon OC is equal to BO upon DO. AO upon CO is equal to BO upon DO. This we have to prove. No, it is AO upon BO, CO upon DO. But it is AO upon CO, BO upon DO. So what is required to make? This is required as our answer. This answer is required. So how we can take out this answer? So what to do now? Cross multiply this. AO into DO is equals to BO into CO. AO into DO is equal to BO into CO. Now here what we want? BO, no? Just write here AO and bring this BO this side for division. And write here this CO and bring this DO this side for division, hence proved. Just we have to shuffle them to take out the answer. So this proving of the question is over. This only it's required to prove that AO upon BO is equal to CO upon DO. Just note it down. Submarine, be attentive. Your focus should be there on the screen so that you can write in time and you should be able to understand the things. Anshit Butler, how have you kept your camera? Okay. Now the next question, question number 10. And question number 10, the diagonal of a quadrilateral ABCD intersect each other. Okay, just write it down as some of the students have not written. Note it down, be quick. A message to everyone. Okay, written, fine. Now question number 10. In question number 10, no, diagonals of ABCD, ABCD is a quadrilateral, and diagonals are intersecting at O, such that this is given AO upon BO is equals to CO upon DO. You have to show that ABCD is trapezium. We have to prove that this quadrilateral ABCD, which they are talking about, it is a trapezium. So let us draw this quadrilateral in the shape of trapezium only, so that we will be able to understand. So here A, B, C, D is a quadrilateral with the diagonals just make the diagonals. Yes, sir, I have given. Okay, so AC and BD are the two diagonals which are intersecting at point O. And what is given, right? This is the only thing which is given in the question. AO upon BO. This we have proved in the previous question, and this is given in this question. So AO upon BO is equal to CO upon DO, and this is given in the question. To prove, we have to prove that ABCD is trapezium, and to prove ABCD a trapezium, what is required? That AB is parallel to DC. If AB and DC will be parallel, then we can say that ABCD is a trapezium. So how? We need again a construction. Draw EO parallel to DC. So I am just making again EO parallel to DC. Okay, fine. Just see in this triangle now, as we have drawn parallel lines here. Okay, so proving starts here. Okay, no problem. You can reconnect again if there is something problem. Within 30 seconds, reconnect. Proof. In triangle ADC, EO is parallel to DC. How EO is parallel to DC? Because we have drawn here EO and DC parallel. Yes, no? So writing in triangle ADC, EO is already drawn parallel to DC, and this is by construction. And because of this, by BPD, we can write AE upon ED is equals to AO upon CO. Okay, and let it be equation 1. Fine, note it down. If you have understood the previous question, if you have understood the concept again, then it is easy to understand this time. The next question, which is 10th, we are doing. Okay. Now EO is parallel to DC, but EO is not parallel to AB. As AB and CD are not parallel, that we have to prove. So this we have done. Now one thing is given that we'll use now. Now what is given in the question? That AO upon BO is equal to CO upon DO. Let us write also AO upon BO is equal to CO upon DO. Given. Do we have anything same here? It is here I have AO upon CO, here I have AO upon BO. So we can again cross multiply and we can make it same. It can be written as AO into DO. Wait a second. So AO into DO is equal to CO into BO. Okay. Now, as here we have AO upon CO. So in the same way here also we can bring this CO this side and bring this DO this side. Now make it equation 2. Now compare both the equations. We have this common, both sides. This and this common both sides. So AE upon ED is equal to BO upon DO. From first and second, equations, you can say AE upon ED is equal to BO upon DO. Now see in the figure. we got this in the final, that AE upon ED is equal to BO upon DO, and this comes in this triangle. See this, if the ratio of the sides are equal, means see this, the point is E and O, and with this AE upon ED and BO upon DO are equal. If the ratio are equal, it means by converse of BPD that EO is parallel to AB. We can write here by converse of BPD, by converse of BPD, EO is parallel to AB. And also by construction we have proved that EO is parallel to CD. Therefore we can say that AB is parallel to CD. As this we have common both sides, EO is parallel to AB, EO is parallel to CD, it means AB is parallel to CD. Hence ABCD is trapezium. Note it down. These two questions are important in the exercise. Question number 9 and 10. After this, now we are going to start, just take out your new page and we'll start the similarity of triangles. Okay, I am repeating the last step again. From first and second, if you will see, there are two equations we have made, this and this. And if you will compare the two equations, then you will get AOCO common. So AE upon ED is equal to BO upon DO. This we get. Now look into the figure. What is AE? AE is this, and ED is this, separated by the point E. And this side we have BO and DO. BO is this here, and DO is this here, separated by point O. It means the ratio of the sides are equal, which are separated by EO. See this E and O. Why no? So if the ratio of the sides are equal, then EO is parallel to AB by converse of BPD. Fine. Is it clear, Mansi? You are asking this? By converse of BPD. Converse of BPD is just the opposite of BPD. If the lines are parallel, then the sides are divided in the same ratio. And if the sides are divided in the same ratio, it means then the lines are parallel. So that's why we have written that EO is parallel to AB. Now one more thing. EO is parallel to CD. This we have written by construction. See this construction. EO and CD are parallel. So EO is parallel to AB also and to CD also. It means AB is parallel to CD, and hence it is a trapezium. Any problem now? Okay. Next. Good. Now the exercise is complete. Now we have exercise 6.3, and before starting 6.3, we should know some of the things. Take out your new page, write today's date. If you are directly writing in your notebook. Soon I am going to call each and every one, means you will get a message regarding the notebook after the test. Just give your test on Friday. I hope every one of you have got the message today. And one number is also means I have sent in the maths homework, and on the same number you have to send me the PDFs. Okay, of the test which is going to conduct on Friday. Okay, just see the message carefully today which we have sent in homework. So 29th of July 2020, starting with similarity of triangles. Just put the heading similarity of triangles. Now, what is similarity of triangles? See, we have studied congruency of triangles. Now we are going to study similarity of triangles. Now there is a huge difference between the both terms, and the same difference I have taught you in the beginning of the chapter. Okay, when I have explained you with the help of this If you remember these images, okay, that what is similar and what is congruent. And the same we are going to study now with some criteria of similarity. So write first similarity criteria. So what are the criteria which we have to use? So how many criteria we have? First is, the easy for you to understand is A means angle, angle, angle. So make two triangles. If I say that in this triangle ABC, the triangles can be of same size or it can be of different size, doesn't matter. PQR. When these two triangles corresponding angles are angle A and angle P, angle B and angle Q, angle C and angle R. So I have marked the same on corresponding angles. Now, if I say that in these two triangles, angle A and angle P are equal, and angle B and angle Q are equal, and I say that angle C and angle R are equal. If all the three angles of one triangle are equals to the corresponding angles in the other triangle, then it means the two triangles are similar to each other. Means triangle ABC will become similar. The sign for similarity is this only. Congruency is this, and similarity is only this. Just remove the equal to sign from congruency, and it will become the sign of similarity. So ABC is similar to triangle PQR. Okay, and which criteria is being used here? By AAA. Means if all the three angles are equal, it means the triangles are similar. Just note it down first this. We will move on to the second. After this, just write second part and write the other criteria, which is AA. Means triple A or double A, it's just same. You can take two angles also, because I'll tell you that why it is possible. Now, starting with AA similarity. Suppose if angle A and angle P are equal and angle B and angle Q are equal, only two angles are equal. Suppose if it's like this. And these two angles are not equal. Okay, if two angles are equal. See, if two angles are equal, no, it means by default the third angle will always also be equal to each other. So there is no need to write the third angle. Okay, you can save your time by writing only two angles equal. So if A and P are equal, B and Q are equal, then by angle sum property we will calculate, then C and R will always be equal. If two angles are equal, then third will automatically be equal. So that's why by AA also you can write that the triangles are similar. So ABC will be similar to triangle, can be similar to triangle PQR just by AA similarity. So AA will also work. Means there is no need to write always the three angles. With two angles also you can prove the two triangles similar. So there is nothing different in both the criteria. They are the same criteria. So here we have took three angles, here with two angles. And after this, write the third. SSS. Side, side, side. Make the two triangles. Now A, B, C, and P, Q, R. How by triple S the triangles can be proved similar? Here sides will not be equal at all. As from the starting of the chapter, I am telling you that here sides will not be equal of the triangle, but the ratio will be equal. So in the same way, we can say that in triangle ABC and triangle PQR, AB upon PQ, AB upon PQ is equal to BC upon QR, means the ratio of the sides will be equal. The ratio of the corresponding sides will be equal. In triangle ABC and PQR, AB upon PQ is equal to BC upon QR is equal to AC upon PR. This way, this is the new way. Okay, means it is just different from congruency. In congruency, sides were equal, but here sides are not equal, but the ratio of the corresponding sides will be equal. If you will write the ratio, means AB upon PQ, then the other sides, BC upon QR, then the other sides, AC upon PR, then their ratios will be equal to each other. In this way, triangle ABC will be similar to triangle PQR by triple S criteria. Keep on writing these criteria. It will help you to understand the next exercise. If you will be able to understand now, it will make your next exercise much easier. Note it down. If you have not written, then note it down. Second and third, AA and triple S. Now after this, no, we have one more, which is fourth point, is the last criteria in this, which is SAS. Now how SAS will work here? Look here now. In triangle ABC and triangle PQR, if I say that AB upon PQ, this and this, AB upon PQ, then this and this is equal to BC upon QR. Only two sides are in the same ratio. If I am saying that this is given in the question that AB upon PQ is equal to BC upon QR, then we need one angle with this. If ratio of two sides are equal, then it will not help us to prove the triangle similar. So we need one more angle. So angle between the two sides. Suppose you have taken this triangle AB and BC, then the angle between the two sides. Suppose you have taken this triangle PQ and QR, then angle between the two sides, that is Q. So if angle B and angle Q, not any other angle, A and P will not work, C and R will not work. Only angles between these sides will work, which is B and Q. If angle B and Q are also equal because of any reason present in the question, then we can say that ABC is similar to triangle PQR by SAS criteria. So these are the criteria which we should know before starting up the exercise. Note it down. Then we'll start with the exercise. See, concept is very important. If you will be able to understand the concept of the triangles, okay, last again I'm repeating, AB upon PQ. See, this ratio AB and PQ, the ratio of AB and PQ, and the ratio of BC and QR, suppose if they are equal, then which angle we should take with this? The two sides we have taken in the ratios, and one angle is also required. Then which angle is required to take? AB and BC sides we have took of this triangle, and PQ and QR side of this triangle. Then angles should be present in between these two sides. Means angle B only we can take. Angle A is not present in between these two sides. See, these two sides are meeting at B. So only this angle we can take equal to this angle, because Q also comes between these two sides. Okay. So that's why B and Q only we can take. So any other angle, if we will take to prove similar, okay, if we are taking any other angle to prove similarity, if we have taken these two sides, then it is not possible. Okay, so this angle will only work. And suppose if you are taking these sides, if you are taking these sides, then this angle will work, because this angle is in between these two sides. Fine, no, I hope you have understood this. The angle that you have to take should be present in between the sides which you have took, okay, for similarity. Okay, after this, exercise 6.3. This is just a question to discuss in the class. So let us discuss this question. Criteria, as I have told you, one is triple S, one is triple A, one is double A, one is SAS. So if any of the pair of triangles given below, you can prove by any of the criteria, then the triangles are similar. Just tell me, this is the first pair given of the triangle. Can we say that these two triangles are similar? I'm waiting for your answers now. Or otherwise, I'll start pointing out the students to answer me. Pratham has written, sir, yes, they are similar. Okay. Yes, by triple A, yes, by triple A, yes, yes, yes. Okay, Jay, Harsh, Samreen, all have written, sir, yes, by triple A. Okay. So let's see. It is very easy, because it is visible clearly that A and P are equal, B and Q are equal, so C and R are equal. So you are asking us a very easy question. So that's why everybody has written. Divyam has written also now. Yes, sir, they are similar by triple A. No need to do the same question in your notebook. Just write it in your book only. Okay. So yes, they are similar by which criteria? Triple A criteria. Okay. Now you need to understand one more thing. Suppose I have made this triangle. Just wait. Suppose I have made this triangle, then I have made a triangle like this. Okay, means it is not made according to my choice. Let me say one more thing. Time, let me try. Suppose just I am trying to say one thing. Okay, if I'm saying this A, B, C, this P, Q, R. Just look into the figure. If I'm saying the name of the triangle is triangle ABC, ABC, triangle ABC, and the second name of the triangle is triangle PQR. Then see this angle is corresponding to this angle. You need to understand the corresponding parts. You can say that, you can't say that, sir, A is equal to R. A should be equal to angle P. Then if B and Q is the other, according to the name, just